Hi, I'm Dan with Connecticut Water. I'm a treatment plant operator here at the McKenzie Water Treatment Plant. Today we're going to be talking about our process and our watershed and how clean water gets to you. This is the Kelseytown Reservoir. It's about 5 days worth of storage, or 19 million gallons total. It's our primary source that feeds the treatment plant. Our secondary source is Killingworth Reservoir, and that's a much bigger reservoir, about 200 days worth of storage and approximately 400 million gallons. The water really starts here at the intakes. You can't see them, but they're under the water, underneath this cage. The water comes in through a set of screens that need to be cleaned every 24 hours by our air burst system. This cage that's mounted on top is an eel lift that's designed to assist American eels on their migration back to the ocean. It uses water current flowing up a tube to mimic upstream currents, and the eels will ultimately choose that path instead of coming into our intake screens and getting into our pumps. And that would be absolutely fatal to them. And then in place of that, they'll go into this cage, and the state will come once a week to collect the eels and bring them back downtown. Part of our operations on the raw water side involves managing reservoir levels and stream flow requirements. There's certain periods of the year where fish are spawning and they need higher amounts of flow. So we try to maintain the stream flow even if we're not spilling from our reservoir using this weir and this valve. We shoot for a minimum stream flow requirement of 1.13 as long as there's no water coming over the top. And part of the way and routine operation here is operating that valve, flushing it out, and maintaining this stream flow. So after the water comes in our intakes on this side, it goes under the driveway and into the raw water pumps that feed the plant. Those will push a maximum of 4 million gallons of water a day up to the plant for treatment. So now we're up in the treatment plant. Where we came from was down here at the reservoir, where our water gets pulled into our raw water pumps. Flowing through this pipe is our raw water coming up from the reservoir. This is where it actually comes into the treatment plant, and this is its first stop in our monitoring. These two instruments behind me are reading turbidity and pH. These are our first indicator that something might be wrong with the raw water quality, requiring a treatment change. This instrument here is what actually reads the turbidity, and it's a measure of how much light can pass through a sample size of water. Depending on how many particles are in the water, less light passes through, it'll give us a higher turbidity reading. Turbidity is important to every step in this process, so pay attention to this 1.5 number and remember that, because you're going to see it get cut in half and then almost reduced to zero throughout our process. Our first step in filtration is coagulation. The idea behind coagulation is to take your small particles, collect them into larger particles called floc, and then sink it to the bottom of this chamber called a clarifier. These tanks right here contain aluminum sulfate. Aluminum sulfate is our primary coagulant in the clarification process that you just saw. Those particles collect together in the form of a sludge and then are mechanically pumped out to our lagoons for disposal. We can achieve 90% filtration through the coagulation alone before it even goes through our filters. This is our clarifier turbidimeter. We have two of these, one for each half of the clarifiers, and this is measuring that same turbidity measurement that we just looked at with the raw water. So if you remember, I talked about how we could achieve 90% removal from just the clarification alone. This is reading a 0.2 right now, so we went from a 1.5 NTU to a 0.2 with just our first step in treatment. So after the coagulation, it goes through filtration. The clean water is pulled off the top, and then it flows underneath this hallway across to the other side of this wall where our 4 filters are located. Our filter media is granular activated carbon. It's the same type of filter media you might use in a fish tank filter or a Brita filter, and that achieves our true 100% filtration. So those 4 filters that are located on the other side of the wall empty into these pipes here down along the bottom, and this is taking our final turbidity reading. So we're at a 0.06 NTU. So we went from 1.5 to 0.06. Now the federal required turbidity standard is a 0.3 for distribution. The filters will take the clean water off the bottom and we'll go into our mixing chamber where we will add our post-treatment chemicals for consumption, our disinfection, and our corrosion control. This next piece of instrumentation is called a streaming current monitor. And this is what's actually allowing us to see the zeta potential in the water that we're treating. So this will change if there's a rain event and a bunch of clay minerals get pushed through our intakes. That would require us to make a treatment change. We would have to change our chemical dosing, and this is our first line of defense. It works almost like a smoke detector, where if this deviates too much from a set point, it will send us an alarm so that we know we need to make a change. This is our lab here at McKenzie Treatment Plant. This allows us to, in real time, assess our water samples and calibrate our meters to make sure that our process is correct in treating the water. We do over 100 different tests a day collectively on physical and chemical parameters of the water. These beakers are representative of our start to finish process, with the raw water here on the right and our finished treated water on the left. This is our control room. This is the brain of the plant. We use a program called SCADA, Supervisory Control and Data Acquisition. That ties all of our pumps, motors, feeders, and valves together into one program that will allow us to independently control them, go through automated processes like a backwash, and generate alarms if there's a process issue. Those alarms are completely automated and they'll call us out even if it's the middle of the night so that we know we have to come in and attend to a problem. The last stop is our clear well for distribution. This is Kelseytown Booster Station. It's the last stop for treated water before it leaves our process and enters a water main for distribution. These are the primary feed pumps that maintain pressure throughout this section of the system. The pumps are run in redundancy so that if there was a loss of power or a transfer, one pump would shut down and the other one would kick on immediately, so there's never any complete loss of pressure in the system.